multi-agent workflows, multi-agent systems, it's all the rage right now. Really cool screenshots on LinkedIn and Twitter, but all the hype doesn't add up to the practical use cases and if it's actually necessary. To help demystify this conversation, we have three of our very own machine learning engineers who are in actual projects, who understand multi-agent workflows when they're necessary and when they are not.
So many clients were coming to us like, please build us like MCP.
Why is everyone so obsessed with this right now?
MCP theoretically is very nice. Theoretically.
With multi-agent systems, you don't always know how to track this error. It gets much, much harder.
Most of the companies don't have the infrastructure behind the...
So let's just do a quick round of introductions. Why don't you just share your name and what you do here at 923? Marius, why don't you kick us off?
Yeah, so I'm an ML engineer building ML systems with vector databases, multi-agent systems, and similar stuff like that.
Okay, so I am an ML engineer as well on behalf of 923 Studio in this wonderful company with my wonderful colleagues. Happy to take part in this podcast.
Hi, everyone. I'm Vitalius. I'm as well a machine learning engineer at 923. So originally, I'm coming more from academical background in computer science, but right now I'm more focusing on bringing ML solutions to production.
All right. So a lot of people see these screenshots online, but it would be really nice to understand what is a multi-agent system and how it fits into this world in just like a plain English.
Multi-agent system is based on a couple of agents inside of it. So one of the agent is orchestrator and other agents are like specialists in their own field. An example, one could be responsible for marketing, other one could be responsible for retrieval from database of some sort of information, and similar things.
And why is everyone so obsessed with this right now?
I could maybe, I would go a little bit historically before that, if that's okay. Maybe before explaining like multi-agents, how did we come up to agents in general, and like what is the reason why do we have like multi-agents? So like first of all, we had LLMs, like everyone knows it, GPT, Gemini, everything, which works very nicely, but it has a limited overview of the world because like the latest information that it knows is only at the moment when it was trained. So it's like 2024, for example. So as if you start asking any kind of questions about outer world that it hasn't seen before, or about like new recent activities, or you want it to interact with any kind of a tools, that's where LLMs can't do the work anymore independently, because again, this is just a large language model. You put some text into it and it just gives you back some text, some output response back. And that's where necessity and opportunity for agents arise. So like, what is actually the agent? It's basically the same LLM, but which has access to some tools. So it can call a specific tool for a web search for the Google, for example, or it can trigger some your specific business API, or it can use some vector database like for some knowledge. That's when we got the hype of agents, of retrieval augmented generation, like basic agents, where it had like a limited amount of tools. But at some point there were too many tools for a single agent, clearly, just for a single LLM to have everything in a single context. That's when we had MCPs, the things which was like super hyped, like 1 year ago, everyone was talking about it. It didn't work out, as you see. It's not as hyped right now, and it was clearly we clearly came to the same thing, to the classical thing in computer science, is like divide and conquer, that you can't solve everything with a single LLM. And that's when we introduced multi-agent systems, that we have a lot of different LLMs, which like where each of it has like a specific role with a specific toolkit, exactly how Marius has said, like there can be like an orchestrator. So everyone has their own role. You don't have like you shouldn't have a single agent which is responsible for both code generating, responding to your emails, and triggering refresh of data, like whatever. So like that's the reason why we got multi-agent systems.
It's always nice thing to have multiple specialized agents instead of one that has this general profile around it. It's way cheaper and the more performative in that kind of case.
You mentioned, Vitalius, that MCPs didn't work out. And I'm assuming you mean like having just one LLM that then has access to everything. But in terms of the MCPs working out in terms of being useful, you still see that value.
Absolutely. It's as any kind of a framework, it's indeed valuable, but it's just only very specific use cases. Because when MCP arrived, it was like a super hype that, this is a solution like for everything, which is not the case. And we had so many clients who were coming to us like, please build us like MCP, and they have like 2 tools, and you're like, you don't need MCP. You don't probably even need like an agent. And we had so many of these tough conversations because it was hyped so much that this is like a solution when it wasn't a solution for a lot of use cases. Because MCP theoretically is very nice, theoretically, but for that flexibility which it provides, it comes like with a lot of bottlenecks, a lot of pricing, latency, reliability like issues, which again like is pretty complicated to solve in production. That's why I was referring to MCP, because I think multi-agents are like in a little bit similar scenario right now. That is, it's amazing thing in specific scenarios, but it's not a Swiss knife where you just like throw it at at any problem. But right now we're again like in multi-agent in that state where MCP was like half a year ago, where like all the LinkedIn everything is just agents, more agents. Let's just throw. It was like throw more tools into MCP. Now we just throw like more agents.
Companies should understand that for every single problem that they have, they should ask themselves if this kind of problem could be solved in deterministic way. If it is solvable with deterministic way, they should like go through regular software engineering and build these tools with regular software engineering. If there's a need of any sort of reasoning, then maybe they should move forward with some linear agent approach. And if that doesn't work, then maybe those multi-agent systems could be introduced. But either way, just don't try to throw every single time the multi-agent system to every single problem that you receive and try to solve it with that. You will have a really, really bad time.
I could maybe just add like a very short thought that what we've been encountering for the last couple of years is that a lot of companies, their solutions are looking for the problems, like instead of vice versa. And we've encountered it with MCP. We're encountering it currently like with a multi-agent. So it's nice frameworks, it's nice things, but only for specific scenarios. But every time something new pops up, everyone forgets about it. It's vector DBs got hype, like everyone is using vector DBs. Do you need it? You don't need it. Doesn't matter. We just throw it like at the problem. And it's history. That's just what's happening. Like in half a year, we're gonna have something new.
Yeah, and here we can talk as well about something called Occam's razor. It is a very widespread principle and philosophy, which probably our listeners are already familiar with, but it states that in 95% of the cases, the best solution is probably the easiest solution. And you should always start with small things and build up on small things if those don't work, because complex solutions usually mean more work, tighter deadlines, higher costs, and you should always consider these factors before jumping into complex stuff.
Yeah, that's so good, because I think something we talk about a lot is starting with the problem for the business and then going to the solution. But it's like the market, it's flipped because it's really appealing. I saw that Claude Cowork Dispatch dropped, I think recently, and I was like, oh my god, this is so cool. It's like OpenClaw, but it's with Claude, and then you start trying to use it as opposed to thinking like, where do I actually have those inefficiencies? It seems like something that happens is you didn't realize what was possible. People don't realize what's possible with simple solutions. So can you talk to me a little bit about when someone actually needs a multi-agent workflow? We've talked about all the times they don't. Rely on deterministic solutions, then go to the linear, and that last resort is multi-agent. When do they actually need that?
I would say the reason to have a multi-agent system is when the amount of roads that are necessary to be taken in order to get the result can't be handled by, regular decision tree. So like what I mean is that every input from the user can or should trigger one system, 3 different systems. It can be, it has to go to 2, 3, and then like to something number 5. So basically, if you can't predetermine the sequence of steps which are needed in order to get the response or like the result of your system, because it's really flexible. It's you give that flexibility to traverse data, to try like different kinds of tools. So indeed, if your solution requires cross references, and it's not always that source one was free, you can't predetermine all the logic needed like for cross reference, for example. So like in this scenarios, you're gonna need flexibility of multi-agent systems.
Yeah, usually you use multi-agent systems in the tool-heavy environments. So, for example, you have a SQL database, you have some weather API or region API where you need to get information from. You have a document search, some analytical tools. So, like different domains, and a lot of those different domains, and the agents need to decide which tool to use. You don't know whether in this case you'll be needing the SQL database or a document search, and the agents will decide which one fits better in your use case.
Nice. That's interesting. Something else I've heard a lot is hallucinations. Like people thinking that multi-agent workflows will reduce hallucinations and increase quality, because now when I threw one LLM at it, my result was weak. But when I threw at least at multiple agents at it, now I have that writer agent, the research agent. So now the outcome at the end should be better. Is that true?
That's a tricky question. Sometimes yes, sometimes no. I think in general, people really overestimate intelligence and underestimate the structure which is required in order to answer. So it depends on your specific problem. So for example, if it's a problem that can be solved by a single LLM theoretically, and you're going to throw 10 different LLMs at the same problem, which don't interact too much with each other, usually you're gonna have a better result, because it's like aggregation, same concept which we had in ML for the gradient boosting, where like instead of a single decision tree, you had like 1,000 decision trees, and then like one aggregation at the top which takes the average. Principle absolutely the same. So in this scenario, it's indeed nice. I mean, a bit like you spend more money, but sure. The tricky part comes when your problem is sequential, is when you have like multi steps that you need to do before you get the result. And the more responsible parts there are in this answer, the more risky it gets, because the problem with these multi-step problems is that errors do propagate. And scary part is not that some part has failed, but it fails confidently. So like the problem is, if you have a multi-agent system where in order to answer the question, like there are 4 agents interacting with each other, if something went wrong on the first conversation between the first and second agent, I mean, it's gonna go wrong up till the end, because like it's very hard to distinguish between like a slight hallucination and like whether this is something correct, because it's always like, it sounds, I mean, that's how they're trained. They are like overly confident, and at the end you're gonna get like you can get a very random response without even realizing that something went wrong, because like on the paper everyone worked, like all APIs worked. You sent something, you got the the output, but yeah, at the end you can just get like believable nonsense, and that was in the details.
LLMs, when they get plausibly sounding output, but a hallucinated output, they compound on it with every single step that they take, if there is linear relationship between a couple of agents. And yeah, Vitalijus mentioned like if there could be multiple agents working in parallel that reduce those hallucinations basically, but it comes at a cost. So with every single new agent introduced in parallel, cost rises, latency rises, everything rises basically. And then you're starting to ask yourself, is it really worth it to have these all of these agents in parallel with all the retry mechanisms that they have? And that cost really compounds a lot.
I could maybe add a quick analogy just to understand it a little bit better. So talking about the problems which we have discussed like more technically, but if we're gonna go with something, very humanish, so like imagine we have a kid's birthday, so like, and you need to choose a gift for a single kid, let's call him Bob, for example. You can give the task like, let's decide what we're gonna, what's gonna be the present to Bob, and you can give this task to 10 kids, and probably you're gonna be all right. So like few ideas are gonna be random, few ideas are gonna be like mediocre, but like at the end, it's gonna be a single output, 10 beautiful young minds came to it and we got some present. Probably you're gonna be all right. But now imagine if you need to plan, for example, a vacation plan, with with hotels, with flights, with everything, where like a single step is relatively okay, but you need to be really sure that, like all the transits, everything is correct. And you throw the same problem to 10 kids where, Anna is responsible for the flight from, from Toronto to London. Bill is responsible for hotel in Toronto. And if something went wrong on the step number 2, what happens like afterwards, it doesn't even matter because you're just going to be stuck like somewhere else. Because like Bill is gonna buy tickets instead of London to to Barcelona, and like literally even if everyone else who has done later stages, like it doesn't even matter. That's probably like the analogy with this kind of systems.
To sum it up, like with traditional modular step-by-step systems, it is much easier to debug, to see where the error was made, at which step it was made, because each component has clear responsibilities and each component like comes one after another. But here with multi-agent systems, you don't always know how to track this error. It gets much, much harder.
And multi-agent systems work way better like if we would be living like in a perfect world where your data is very clean, all the APIs are well documented, there are like nothing, but it's not the case. The problem is that same what we had with microservices, like 15 or 20 years ago. So same is with AI right now. Like a lot of companies are like, they are not really adopting AI, they're just duct taping it, because in order to have like AI, you need to have like you need data maturity, you need processes, you need like a lot of stuff to be in place. And like the issue is that still a lot of companies, they want to invest into AI, but you can't solve everything by just throwing some LLM. Yes, it is smart, but no, it's not going to solve, like if your data is garbage, it's not going to solve it, or it's going to be so much expensive and like really not performant. And that is important because yes, and for that multi-agent systems, like it's marginal increase of that error. That's like the problem. I can give you like an example. Like I probably can't tell the name of a client, but basically imagine like a multi-step system for negotiating your like schedules in your calendar, and data was wrong. And we're like in the output, there was a user interaction, and what we got is that user had some appointment which started after it was ended. So some random nonsense, and we're like, how did we come up here? So we go to the first system which is responsible for answering to the user. Everything is correct, and down the line, and then at the end appeared that like in step number 2, agent which is responsible for actually checking the flexibility of your appointment, it hallucinated one number, and like appointment which was 30 minutes, it decided that it can reduce its duration by 60 minutes. So, you're going to have a negative 30 minutes, which, for any human being is like something, very logical. But this is LLM, it like that system was not responsible for validating whether minus 30 is valid or not. It just passed that it's minus 30. Another system just, made a change that, according to that number, and like so on. So theoretically everyone was right, but like in practical we got absolutely nonsense in the output, and it takes a lot of time. And this is indeed, as Alexei said, it's like debugging of such systems, it's like it's archaeology because you literally you don't know like what's which exactly part, like where did it, like you need a way more like monitoring like traces and like to really see where it goes wrong. And the problem is that one time it hallucinated, another time it didn't hallucinate, because it's not deterministic. It's not that you wrote some code wrongly and now it just fails. It can happen, from time to time, like 1 out of 100 times. But like if it's something critical, you can't accept it. This is a very scary thing because you can learn sometimes you can learn only quite late that something is wrong, because during the basic testing, it's not even visible.
Wow. You mentioned the things that don't excite you. Someone just sharing a screenshot of a workflow, someone saying, hey, let's do a multi-agent system just because I heard it's cool. What are the projects that do excite you? Or you mentioned data maturity. What are some of the signs that you see when you get on that scoping call and then you're like, holy crap, this is going to be amazing. My life is so much easier, because this is going to help our audience prepare themselves to be in a great position.
That's a tough question. I think first of all, clear understanding of what we want to achieve. I mean, this is very basic, but like so many people, they're like, yeah, we just, we want everything to be fixed. We want to, cure cancer, and it has to be fast. It has to be so. Like you need to reasonably understand what you are trying to achieve. What is your budget? What is your latency? Another example. I think it's a bit random, but I mean, maybe we can include it. It was quite interesting. I was working on a project in purely medical domain, but very deep tech. It was human, like data on a human cell level. So like very like medical genes like stuff. And at the beginning they were like, yeah, we want as flexible as everything, and like that's what we have, that's what we want to achieve. And like the system was performing quite nicely. And then I asked like a single question, was like, how much does it cost? Like, yes, this looks nice, but like how fast it is. Because demo looked like unbelievable. They showed like, we want to do something, something like this. I was like, okay, cool, But when starting going into the details, it appeared that outside of that one demo question, average interaction per query was like $1.5, which, imagine like, how can you, like if you feel like, if you look into demo, like sure, but if you're like a business, you need to understand return of investment. This is like super important. That's why it's important to choose appropriate tools, because like appropriate frameworks, appropriate AI, you call it, because even if it's gonna work out for you, it has to make sense for you, like in production, like on your scale. Because yes, if multi-agent solved your problem, but then like a single interaction costs you like $1, and you have a subscription which costs $5 a month, you're going bankrupt. That's basically it. So first of all, I mean, it sounds boring, but you need to go from constraints perspective. You need to understand what kind of constraints you have. So like, what's your budget? What's your latency? Whether your backend can even, handle something like that. We had a lot of, scenarios where actually integration from clients is just not working out because, their backend doesn't support that. You need to think about these like boring things, that your data is structured, your data has less, hopefully not too many duplicates. It's clear relationships. You have descriptions. You have people to maintain it, because like the fact that you've built it, once, it doesn't mean that it's not gonna get outdated like in half a year, because you should keep improving your systems, because there are like data drifts and like all of that stuff. So this is, first of all, yeah, you need to understand like what it is. Second, my favorite is that if people have some basic understanding of what AI is, like of AI capabilities, because like very usual, and we're getting that frequently right now, probably we're gonna get that even like more frequently. People have, with all the news, with all the, LinkedIn posts, everything, people are very strongly overhyped. They very strongly, not overpromise, but I mean, they don't understand what LLM is. It's like, when you have like a conversation when someone's telling that, we all remember that was the case where LLM is not able to say how many R letters are in strawberry. If you don't understand why, like that's it. You can't build a multi-agent system, because that's technical limitation, and like the ones who were telling that the LLM is dumb because it can't do that, and the ones who were telling that LLM is smart now because it can count, like they both don't understand how it works. So it's I think, yeah, this is, yeah, I think people who are not looking at the single solution as a Swiss knife where you just plug and play and like everything works, I think this is very important.
So, Nashan, a little bit back to your question on how the company should look like. So basically, what you described is a unicorn company. They mostly do not exist or are extremely rare, because most of the companies don't have the infrastructure behind the AI that would support the AI. You need a really strong infrastructure. And when companies come to us and say, okay, could you build us a ML model or AI model that would predict 3-5 years in the future, but they have like 3 years worth of data? How can we do that? How can we like grab those seasonal patterns? How can we grab any sort of seasonality from that sort of data? And it wouldn't be accurate as much as they want it to be. We are ML engineers. We're not magicians. Like, we cannot pull a rabbit out of hats, really.
We're magicians.
Yeah, and it's always a big relief when we have engineers from the client side, like technical people from the client side as well, on the scoping calls and the just regular client things, because it is much easier to follow all the processes, because the engineers from the client side can explain to their CEOs like the real state of the problem, because maybe non-technical people really think it is magic when it is not in reality.
And I think one more reason for that is that a lot of teams, especially like C-level executives, like I mean, I can't call it a mistake. I mean, it's, I'm biased, I'm an engineer, but I think the issue is that people optimize for edge case intelligence instead of reliability. So, to impress CEO or your investor deck, you're going to make a multi-agent system, which in this, specific demo, gonna draw you diagrams, gonna do like whatever, but out of like 100 regular use cases, it's gonna fail, for example, like, in 15%, scenarios. And with such an architecture, you're never going to be able to achieve like 99 or something like that. And like, so, but you're not going to impress, you're going to way less impress most of, salespeople with reliability, because it's like, it sounds boring. But to have it, it's way harder, to have more or less deterministic performance in this kind of systems, like 100 times harder than, to give like a quick demo. Quick demo, you can vibe code it, you can show, something. But like the tricky part is that, like the fact that it's working, like success rate of 90%, it doesn't mean that, you're going to have like a 10% catastrophic behavior. If something, some sensitive data, if there is, a 5% chance that you're like a sensitive data is going to get leaked, your system can look, like a wizard, but like if that's going to happen, you're not going to be happy, because of those fancy things. And this is, I think this is very important, but got neglected by a lot of businesses right now.
Yeah, AI demos are really shiny. Like whenever you post something of a demo from AI perspective, usually it blows your mind. But the thing is, what is behind the scenes? You test this demo for this specific question and these specific drills, and you know that it works on these drills. But whenever another question like would be asked from different context or different somewhat, then it will definitely show that it fails or something. So it's they are really shiny, but in production they are really hard to maintain.
My suggestion would be, if you build something in production, like hopefully you're going to be building that with people who are not looking into multi-agents as the only solution. If that's the only proposal which they give to you, I mean, most likely like you're going to be in a trouble. It's always like it's never a win-win situation, in most of the solutions. So whoever you work with, you want these people to see how it was built before, how it is being built right now, and probably have some kind of understanding how it's going to be built in the future. So don't work with people who are running for the hyped frameworks, because if you're gonna do it, like I truly believe that like in 1 year, like half of AI code is gonna be like replaced, because it's just gonna go absolutely like what's happening with MCPs. Coming back like to that one. So try to work with people who understand how these things work under the hood, not only like the input output, not only achieve in demos results that you want to see, but actually understand like the drawbacks and like how this stuff works. Because I mean, a lot of businesses do struggle with that. And like, it is, it's fun to jump on, on AI hype, and, with a lot of technologies, that's how you happen. You try something new, something doesn't work out. But with these new solutions, with providing accesses to sensitive data, to some important infrastructure, you can cause like really a lot of troubles, really a lot of troubles. And that's what especially, I mean, that's probably like a whole different episode, but that's what we've seen, especially like lately in the news, like with McKinsey, with Apple. Like Apple just has as well like a new restriction: you can't deploy, I think, any code which is vibe coded, any apps which are like vibe coded, like and there's a reason for that. In Amazon, like the company which was like, I mean, one of the strongest like in ML companies like worldwide, if your code is at least was touched by AI, you have like special rounds of code review, and there is a reason for that. They learned it in a hard way. So it's better to learn from mistakes from other people instead of dropping your own prod database.
Yeah, and to add to that, I would say that always work with people who can explain the steps and explain why something is needed to be done. So if they say that multi-agent system is the best solution here, it needs to be explained why it is so. If they are saying that like some classical machine learning algorithm is the best here, they need to explain why it's so. You need to work with people who understand the problem and understand the solution, not
On
only
my current project,
build on hype.
I just wanted to add, because it was similar, like literally on my project, one of the projects which I worked when, it started with like 1 hour session with CTO, where I was literally introducing, okay, here is your problem, here is your pain point. We can go with modular approach. We can solve this as well, like with multi-agent approach. Okay, I mean, I can make it work like in both ways, but like, if we go this way, we're going to have like these pros, these cons. If we go this way, we're going to have these pros, these cons, more or less like timelines, like, and everything. So, because at the end, you consult, there is not, a gold solution. If someone is pushing you a very specific technique, that it's only like this and like not anymore, like probably they're wrong, probably they're just, pushing you their own preferences, because like any kind of solution is going to have, it's going to have its own problems and strong parts. So try to find people who can guide you, like, honestly, not vendor locked, not technology locked, who try to really understand your pain point and solve it as efficient and like in the best manner with using like machine learning, which are not, just, okay, I learned like this tool, so now I'm gonna, now I'm gonna throw it at any problem. So I think this is very important.
Yeah, our job is to provide client with options. It shouldn't be deterministic on, okay, we will build this and nothing else. Sometimes it's a little bit hard to be the adult one in the room, the realistic one, basically, because everything is overhyped right now. Everything is building something interesting, something new, something shiny, and they want to build that shiny thing as well. But when we sit down, we we are reducing their expectations on what could happen with the infrastructure that they currently have, or what could happen with the pain points that they feel really, and usually it cuts off their smile from their face. But we just try to provide reasonable solutions, not overly hype stuff for them.
Because we try to give consequences of your expectations, because when it's just like a fancy feature, it's very, very easy to say yes. But if you heard that, yes, okay, we can do that, but it's going to cause like 20% in latency, 30% like in costs, and like as well, like the, some parts are going to get like unstable. CEOs don't like to hear it, but I mean, it's better to come, before actually you implement it and you learn it in a hard way, like with the user. And like when you get to work with, with many projects, you start seeing these kind of patterns. So like, yes, usually it's exactly how Mario said, it's in these meetings, like usually we're party poopers because we're like, we bring that, expectations to like where the reality is in terms of technology, and then like what kind of consequences it has, because usually it does.
Guys, this is an amazing episode. If you found this interesting and you've thought about doing multi-agent workflows, you're not sure where to start, we're actually not going to suggest a tool. We're going to suggest that you get a strategy template with the first link in the description. It'll walk you through doing exactly what they've talked about doing here, which is analyzing your business, your bottlenecks, your pain points, prioritizing, and then creating a technical implementation plan for what path makes the most sense. Guys, thank you so much for being on.
Thank you.
Pleasure.
Thank you for the opportunity.